let's continue with our topics for today. So we talked about these new things called confidence intervals, which are things that like aren't very intuitive to us. I feel like these are a lot of the previous topics were things that you've at least like seen before, like you've heard about the mean, you've heard about the mode. So at least you had some intuition on. The confidence intervals weren't like that. Okay. If you weren't in class last time, just remember to watch these two videos. I basically explained this thing called the range game, where we had this red interval that the contestant would go and guess the price of something. And if the actual price or what we were interested in landed in that interval, then the contestant won, right? So we're basically playing this game, but instead of guessing like how much a trip to Rome costs or how much a trailer costs, we're just guessing the population mean for any sort of given question. Okay, so just a reminder, whenever I use symbols in this, we have 4 different symbols. They're kind of hard to memorize. Whenever I use these, the population mean uses mu, population standard deviation, lowercase sigma, or the cherry. Sample mean is x bar, and sample standard deviation is x. If you ever get confused what symbol you're looking at, just go back to the green chart and we'll tell you. Okay. We started out with this example. We talked about a simple random sample of 100 fourth graders, and they were selected to do this new approach in reading. Okay. And to test if they actually like benefited from that approach, they were given a standardized reading test. Okay, so all these students got a sample mean of 67.3. And it's also known that from the past, the scores on tests have a population standard deviation of 15. Okay. The question is asking us to guess the population mean. Okay. Now our answer here isn't going to be an actual number. It's not going to be like 3 or 5 or 16. Our answer is going to be a range of numbers. We're going to try to give a little range of numbers that we think the population mean might be. Okay. But we're not really confident, right? We could win the game, we could lose the game. All we're interested in is the population mean in this interval that we come up with. Okay. Now, we didn't really talk about how to come up with that interval. We'll talk about that today. Okay. And I think we talked about yesterday or on Wednesday what the best estimate for the population mean was. Does anyone remember what that was? Like, what was the best guess for the population mean? Oh, close, but I think you're skipping a step ahead of me. Like if you were given that, okay, the sample size is 100, the sample mean is 67, and the population standard deviation is 15. That's all we knew. And I was like, what do you think the population mean? What would be the closest number to the population? Yeah, the sample mean, because it, like they're both means. The sample mean might not be the population mean, but it's going to be somewhat close, right? As long as the sample is representative of the population. Okay, so we called 67.30 or the sample mean our point estimate because it's the best estimate for what we're looking for. Okay, it's the closest thing to the population mean. Okay, now it's pretty unlikely that the sample mean is equal to the population mean. So instead of saying it's equal, probably not, we're going to create a range of numbers. To do this, we worked with this idea of the margin of error. Okay, the margin of error is going to tell us how big the interval is going to be. Okay, so for example, if the margin of error is 10, we could take our point estimate, add 10, subtract 10, and then I would have an interval of 2 numbers, 57.3 and 77.3, that the population mean might be. So all I did is when I write it like this, I'm adding the number 10, subtracting the number 10 from 67. I have a question. I kind of pulled 10 out of thin air. What if the margin of error was 2? Okay, what or how would I find the 2 numbers that I would expect the population mean to fall between? How would I find those 2 numbers? Yeah, I think I see what you're getting. Like So our margin of error here is going to look like very similar to the last one. I'll put the point estimate in the middle, kind of like that center point of our estimate. And here I'm going to subtract 2 and add 2 to the point estimate. 67.30 plus 2 is 69.30. And I can subtract 2. And that will get me 65.3. Okay. So here I can say that my range is going to be between 65.3 and 69.3. As the margin of error gets bigger, is the range going to get bigger or smaller? Bigger, right? Because we're adding and subtracting larger numbers to the point estimate. And I guess as the margin of error gets smaller, our confidence interval is going to be very big. Okay. So all the margin of error is doing is telling us how big or small our interval is going to be. Okay. Any questions so far? All right. I lost my notes. I don't know what I'm looking at. Okay, here we go. Let's flip our page over. I think the biggest question we have here is, okay, we understand the point of the margin of error, but I've been just pulling out random numbers, 10 and 2 out of thin air. How do we actually find out how big the margin of error should be in a certain situation? Okay. It really depends on how confident we want to be. Remember, when we looked at the ranging, we said that a really large interval is good to win, right? Because we get more prizes, but it's not as meaningful as a small, but as winning a small interval, right? Winning with a large interval, well, everyone can do that, but a small interval means a lot more. It means you're probably better at the game. Okay. So I'm not going to explain to you yet what the term 95% confident means yet, but we'll get to that soon. Okay. Let's just say I want to be 95% confident. Let's figure out how large to make that margin of error and see how big or small we can make our interval. Okay. Here's where things get kind of weird. If you wanted me to explain this in further detail, you can come to my office hours. I'm just going to tell you that we're using the central limit theorem to do something. Okay. So we're just using the central limit theorem that we learned in the beginning of the week to do something. And we're going to find this value that we call the standard error. Okay. So the standard error is sigma over the square root of n. That's the population mean over the square root of the sample size. Okay. This is the same formula as we had in the central limit theorem, right? Same formula. So I want to memorize it. But it's pretty easy to memorize because you already have to memorize the same formula for a different application. So bear with me right now. You're gonna be like, what in the world is this? Let's just hear it. Okay. So let's go back to the first page where we had example 1. I want you to find the standard error in this example using those numbers. I'll be around to look at your answers. Okay, so in example 1, I know I should put this in the sheet, but we need to find good. All right. I've seen some. Oh no, you're actually doing a really good job with that calculator. That's really good. You can still work if you want, but let's just come together. I saw some nice answers up here. Remember, I'm just going to write down what our example is so we have it. I think n was 100, right? The sample mean or point estimate was 67.3, and the standard deviation was 15. Okay. So when we set this up, what number went on top? 15. And the bottom was the square root of 100, right? Now, my best advice to you is to do the square root first, and then do the root. I know it sounds really stupid, but sometimes when I type this in my calculator, it works kind of mess up. What's the square root of 100? Good, 10. Okay, and 15 divided by 10 is 1.5. So the standard error in this example is just 1.5. Any questions so far? Okay, we still want to find that 95% confidence interval. I know it sounds a little crazy. Don't worry about what that means yet. Next, we're going to find this thing called the critical value. Okay. Now, I don't want to go too much in depth of what this means. If you're curious, it stems from the normal distribution and how confident that we are. Okay, it's one of the probabilities in the normal distribution. That's all you kind of have to do about this. We're going to find the critical value, which comes from this bell curve. And normally, well, you have to like actually calculate it, but I'm going to make it pretty easy. Since statisticians do this all the time, they've actually created this nice chart that shows the critical values for different levels of confidence. Okay. So since we want to be 95% confident, what do you think the critical value is here? Awesome, awesome, right? We would just go in the chart and be like, oh, 95%, 1.960. So the value here, 1.960, is the critical value for this example. One thing about this chart, I'm never going to require you to memorize this chart. Okay, I will always give this to you on a test or quiz or anything like that. So this will be given. I will give this to you. Okay, so never be stressed out about having to memorize the chart. This will be always given to you. Okay. So we found the standard error. We found the critical value. Any questions before we move on? Here's how we find the margin of error. Remember that thing that tells us how big or small the interval might be? Okay. The margin of error is found by doing this. We take the critical value and we multiply the standard error. We just multiply them together. All right. So if I were to find the margin of error in this example, what two numbers am I multiplying? Awesome. Okay. So we just take the critical value, we take the standard error, and we just multiply them together. I'm getting 2.94. Okay. So instead of my margin of error being 10 or 2, my margin of error now is 2.94. Okay. If I want to create a 95% confidence interval for the population mean, I can write this one of two ways, and we've already kind of seen this. Okay. The first way I'm going to write this is, I'm going to take the point estimate, right? Just like we did before. Point estimate. I'm going to write a plus or minus sign, and then I'm going to write the margin of error. Okay, so I'm taking the point estimate, the thing that most represents the population mean, and then I'm going to add and subtract the margin of error, and that's going to tell us how big our confidence interval is. What number is our point estimate in this example? Yeah, 67.3. That's the sample mean. Okay, I'm going to write plus or minus the margin of error, which is 2.94. Okay. So this is one way to write the confidence interval. It's saying 67.3 is in the middle, and I'm adding and subtracting this number. Okay. Another way we can do this is, my Apple Pencil is not doing well because I dropped it. It's too sad. Okay. Our interval is going to be a range of numbers. Remember, the point estimate is that thing that is kind of like our base point. So 67.30 is definitely in the middle, right? So we can add and subtract, right? 67.30 plus 2.94. I think that's 70.21. And then I can take 67.30 and subtract, right? And that's getting me 64.36. So the two numbers that my population mean might be between, I don't know, is going to be the interval. Oh my goodness, my Apple Pencil. No. 64.36 and 70.21. Okay, so whenever you have a, oh yeah. Oh my goodness, I'm very bad at doing mental math, so let me just check. I know, yeah, you are totally right. This should be a 4. Thank you so much, Jasmine. Makes me so happy. Students catch on to what I'm writing wrong. Okay, thank you so much for that. Okay. So whenever we have a range of two numbers that make the range of values, we can write it in this is called interval notation. We take the lowest number and the highest number. That kind of represents that big red interval numbers, like on the Price is Right. Another way we can do this is using less than signs. Whichever one is comfortable for you is fine with me. Okay. We can take our lowest number, use a less than sign, right? And we're trying to calculate the population mean, right? So the population mean we're saying is in between the two numbers. So I'm just going to kind of stick it in between the two things that I just guessed. Okay. So it doesn't matter to me which one you use. I think the interval notation is a little bit easier because you don't have to remember the symbols here. But either way would be fine with me. This is another way to write your answer. Any questions on how I got? Yes. One thing is, I think on some of the questions, I'm going to ask you to do the plus or minus version and then find the two numbers. So you might have to do this one and then one of the other two. That's a good question. Any other questions? All right. So finally, once we find the interval, sometimes we're asked to interpret our interval in words, okay? Now, I hate to break it to you, but statistics is very finicky with language, okay? A lot of things in statistics, unlike other math classes, is you can get the right answer, but then you might say it the wrong way, okay? We'll talk about the right and wrong ways to say things right now, but it's very important that I phrase this in a particular way. I'm going to say this. We are, in this case, 95% confident that the population mean, the thing we're trying to find, the population mean mu is between 64.36 and 70.24. Okay. We'll talk more about how not to write the answer, but I do want to make it clear that this is kind of the baseline of how you would write the answer for any of these types of questions. Any questions on finding confidence intervals? Okay. This seems kind of, I don't know, spaced out a little bit. I think you might be confused with all the different steps. I'm going to take you through a question later on that leads you through each step. Okay, so if you're getting confused about each of the steps, just bear with me until we get there. Okay. All right, let's talk about what this actually means. Okay, I've thrown around the words 95% confident, 80% confident, 99% confident, but I haven't really explained what that actually means. Okay? Here's what this is. Let's say we want to be 95% confident. Okay? Let's pretend we're playing the range game. Okay, we're at the Price is Right. We're watching the range game get played. Every single time the range game gets played, they're gonna hit the button and the red interval is going to be like this. Okay. Then maybe another contestant has the same question and they play the range game and get this interval, right? And then another person plays and gets this one. And another person hits it and gets this one, right? Okay, out of all the red ones that I've highlighted, which ones lost the game? Right, because the population mean or the thing we're trying to guess is that black line right down the middle, okay? All of these guys won the game because they include the population mean. This guy lost. Okay. Now, let's say a bunch of contestants played the game over and over again, and we had like 1 billion contestants, and they all played the same game, and they all did this. This would be all of their scores, right? We played it 1 billion times. Okay. What 95% confidence means is that 95% of them are going to win and 5% are going to lose. Okay, so this guy over here is part of the 5% of people who lost. Okay, everyone else gets to win. Okay. So our confidence level doesn't really tell us about like the probability of the mean being in like any specific confidence interval, but it kind of just tells us, okay, if we did this process over and over and over again, we had so many range games getting played over and over and over again, 95% would win, 5% would lose. Okay. Does anyone have any questions about like what this actually means? I know it's kind of a hurdle to get through. For some reason, I always have problems with like interpreting confidence intervals in words and trying to understand what it actually means. But I think thinking about it in terms of the range game makes sense to me. Okay, now I have this section called piecing things together. We're actually not going to piece everything together here. Okay, I'm just going to give you some practice in creating these confidence intervals. Later on, we're going to piece everything together, but this is piecing more things together. Okay. So we don't just have to make a 95% confidence interval. We can do other ones. So here's an example. We have a sample of size 50. Okay, so n equals 50 here, right? And it has a mean x bar equals 7.1. Okay. It also says the population standard deviation is 2.3. What symbol does population standard deviation use? Good. The circle with the line on top. Sigma equals 2.3. Okay. This question is asking us to create a 90% confidence interval for the population mean. Okay, so we want 90%. So if we played the range game over and over and over again, 90% will be winners, 10% will be losers. Okay. Let me get these notes here. I'm on the wrong page. There we go. Here's how we go about doing this, okay? And you might be able to piece together your homework right now based on what we do, but maybe not everything, okay? But this question will kind of clear things up for now, okay? The first thing I want to do is kind of go in the order of what we did before. First, I'm going to find the critical value. Does anyone remember how to find the critical value? Yeah.
And it would be 1.6.
Awesome, awesome. So you would go back to that chart on the last page, and since it's a 90% confidence interval, well, 1.645. Nice job. So we found this using the chart. So that was pretty easy, right? All right, next we'll find the standard error. Okay, what's the formula for the standard error? Same one you have to memorize for your quiz. Uh-huh. Awesome. Standard deviation over the square root of n. Okay. Looks like we can plug in some values. 2.3 over the square root of 50. So my best advice is to do the square root of 50 first. So I actually didn't do that in my notes. I'm kind of a hypocrite today. but the square root of 50 ends up being 7.07. Now I'm going to go in my calculator and do the division, and that gives me 0.325. So I found the critical value, I found the standard error. Let's find the margin of error. Okay. How do I find this value? Yeah, multiply the two numbers we just found, right? We're going to take the critical value, 1.645. We're going to take the standard error, 0.325, and just multiply them. So I'm getting 0.535. So the most important number here that we found is the margin of error. We're going to use this to make our confidence interval. So interval. Two ways to write this. Who wants to give me the plus or minus version? What would be the first number? Awesome, right? So the point estimate or the sample mean goes first, right? That's the base point of our estimation. And then we're adding and subtracting the margin of error. Okay, so this is one way we can write it. Okay. Then the other way we can write this is add 0.535 and subtract 0.535 to 7.1. Okay, so I'm going to take 7.1 in the middle. I'm going to add 0.535. And let me see what that gives me. I think that ends up being 7.635. I'm going to take 7.1 and subtract 0.535, which gives me 6.565. Okay. And these are the two numbers in my intervals that kind of represent the lowest and highest points. So if I were to write this out, I could do interval notation, 6.565, comma, 7.635. I could also use the less than signs too. 6.565, less than the mean, less than 7.635. Okay. So, oh yeah.
We have to draw that out. We just like write it to the front.
Oh yeah, you don't have to draw this, like this thing here. I like to visualize it. I don't know, that's kind of how my brain works, but if you just want to add it, subtract. All right. Any questions on how I got example 2? All right, let me check on time. Yeah, I think we have enough time to try out example 3. Yeah, why don't we give example 3 a try? Come back together here. I got some nice answers on the board. And I guess we'll do the interval together since I forgot to ask you. So we have a sample of size 42. So n equals 42 here. The mean is 9, and the population standard deviation is 1.5. Okay, so all of this stuff are critical value. Who did I ask to write this one out? Do you want to explain how you found this one? Mhm. Awesome, right? So you found the chart and it just said 0.253. Okay. Okay. Standard error. Did I get? Let's write that one up. Do you want to explain how you got this one?
So,
All right, sounds good. So the standard error. Oh man, my Apple Pencil is breaking up. Okay, that ended up being 0.231. And then the margin of error, forget who I asked.
it was me. I think it's a little off because I read it as 45.
Oh, okay, that's fine. let me check my notes. Oh, shoot, okay. I should have looked a little closer. But I think you should have gotten 0.58. Does that sound okay? Okay, you're good. Okay. So this one should be 0.58. And of course, you found it by multiplying the two numbers. Oh my goodness. Sorry. Okay, then you were asked to find the confidence interval, right? Does someone want to give me their plus or minus interval? Awesome, right? Point estimate plus or minus marker there. And what two numbers did everyone get? Did you?
I got 8.942
Uh-huh.
and then 9.2.
Right, that looks good to me. Okay, if you wanted to write it using the less than sign, totally fine with me. But these two are good. Okay. Now I didn't ask you to interpret the interval in words, but does anyone want to take a crack at interpreting this using the format we used last time? Awesome. Nice job. I'll write that out. So Alyssa said, we are 20% confident that the population mean, or mu, I'm just going to write mu because I'm lazy, is between 8.942 and 9.058. We'll talk about how to write that in more detail later. But how about this? We'll stop here for now. And I think we have a quiz to take. No April Fools here.